Hi everyone, welcome to this channel. So today we are here with another tutorial video, and this video we are going to be learning about Snowflake architecture. So we have already published a tutorial video on introduction to Snowflake. So if you are someone trying to learn Snowflake from the beginning, you can just go ahead and watch that video first. So it will be a little beneficial to you in terms of learning Snowflake. And yes, let's just quickly jump into this tutorial. So the topics that we will be covering in this tutorial would be, we will learn about Snowflake architecture. Consequently, we will have a look into shared disk versus shared nothing databases. We will see the components that are present in Snowflake architecture. And eventually we will see how to run Snowflake and how to connect to Snowflake. Okay, so let's just jump right in. So if we talk about Snowflake architecture, it is a hybrid of traditional shared disk and shared nothing database architecture. So Snowflake's architecture is a mixture of both shared disk and shared nothing database architectures. How? Let's see that. So similar to shared disk architectures, Snowflake uses a central data repository for persisted data that is accessible from all the compute nodes in the platform. So we have a central data repository, and all the compute nodes that we have enabled in our Snowflake platform can use that single central data repository. And this enables the shared disk architecture functionality. Now, how does Snowflake leverages shared nothing architecture? Let's see that. So similar to shared nothing architecture, Snowflake processes the queries using MPP, which is the short form of massive parallel processing. So Snowflake, it processes queries using this MPP compute clusters, where each node in the cluster stores a portion of the entire data set locally. This approach, it offers the data management simplicity of a both shared disk architecture, but also with the performance and scale out benefits of a shared nothing architecture. So this was the brief introduction on Snowflake architecture. Now let's look into shared disks databases. So in a shared disk architecture, all the data is accessible from all cluster nodes. Any cluster can read or write any portion of the data it wishes. So we have a single central data repository and all the cluster nodes that they can access that data repository. They can read data, they can write to the data as per the cluster node requirement. So how does that come in contrast to Snowflake? In contrast to Snowflake, we have a central repository to store persistent data that is accessible from all the nodes. By nodes, here I mean cluster nodes. So in the diagram, we can see that we have a single data repository and we have multiple compute nodes. So all the compute nodes are able to access the data repository, and the data stored in my data repository, it is shared by everyone. Now let's talk about shared nothing database architecture. So a shared nothing architecture, it is based on multiple cluster nodes replicating data in real time. So how does that come in contrast to Snowflake? So in contrast to Snowflake, Snowflake processes queries using MPP compute clusters, that is massive parallel processing compute clusters, where each node in the cluster stores a portion of the entire dataset locally. So this is how Snowflake leverages the shared nothing database architecture. So if you look into the diagram, we have a portion of the dataset available for all the compute nodes. So we have multiple compute nodes, and each node, they have a portion of the dataset stored locally. So this was for the shared nothing architecture. Now let's jump into the Snowflake architecture and see what are the components in the Snowflake architecture. So the Snowflake's unique architecture, it consists of three key layers. We have the database storage. Another layer, we have the query processing. And for the third layer, we have the cloud services. So the Snowflake architecture, it comprises of three unique layers. For the storage part, we have the storage layer. For the query processing, we have the query processing layer, which is comprised of virtual warehouses, which will be eventually seen. And for the cloud computing part, we have the cloud services layer. Now let's look into all of these layers individually so that we can have a better understanding on each. So talking about storage, a Snowflake database storage is where an organization uploads the structured, or we can say the semi-structured data sets for processing, analysis, or whatever the business requirement may be. So the storage layer in the Snowflake architecture is responsible for storing the data. And as we can see, Snowflake automatically manages all parts of the data storage process, including organization, structure, metadata, file size, compression, and statistics on that data. So these key factors, that is the organization, structure, metadata, file size, compression, and statistics, these are handled automatically. These are managed automatically by Snowflake. Now let's look into the second layer in the Snowflake architecture, which is query processing. So this is referred to as the muscle of the system, muscle of the Snowflake architecture. This layer is responsible for massive parallel processing. The compute layer of Snowflake, it is made up of virtual cloud data warehouses that lets us analyze data through requests. So let's suppose I have a data set. I'll give you a practical scenario. I have a CSV file that is stored in my Snowflake storage layer, in a database in my Snowflake storage layer. And I have to perform a transformation on that data, any kind of transformation. So what happens is we run the queries using this query processing layer. And as we can see, the query processing layer, it is comprised of virtual cloud data warehouses. So whatever request that we make, whatever query that we make to perform any sort of operation on the data, it goes through the virtual cloud data warehouse that is making up this query processing layer in the Snowflake architecture. Okay, so each Snowflake virtual warehouse is an independent cluster, and they do not compete for computing resources, nor do they affect the performance of each other, which means that workload concurrency is never a problem. So what do we mean by that? I will try to break down. So let's suppose I have a person from a data analyst team and a person from a data scientist team. Both the teams, they have to work on a single data source. So what happens is my data analyst team, they will have their own individual virtual warehouse to perform any kind of operation on the data source. And my data scientist team, they will also have a separate virtual warehouse, a dedicated virtual warehouse to perform operation on that same data. So what happens? What is the advantage of this? Is the queries that my data analyst team runs, that queries does not affect the performance of the queries that my alternative team, which is data scientists, they are trying to run. So this brings us to a conclusion that workload concurrency is never a problem in Snowflake. Okay, so now let's look into the third layer, which is the most important part, most important component of the Snowflake architecture. And hence, so this layer is also referred to as the brain of the system, as the brain of the Snowflake architecture. This layer, it manages the infrastructure, security, access control, metadata, and etc. So this layer is mainly responsible, the cloud computing layer is mainly responsible for managing the security, access control, infrastructure, and metadata. Snowflake uses NCI SQL for cloud services, empowering users to optimize their data and manage their infrastructure. The security and encryption part of the stored data, it is managed entirely by Snowflake. Snowflake maintains robust data warehousing certifications such as PCI, DSS, and HIPAA. The services that this cloud computing layer offers include authentication, infrastructure management, query parsing, optimization, metadata management, and access control. So don't be afraid of these individual terminologies. We will be publishing tutorials on these terminologies in the future. But for now, just keep in mind that anything from authentication, infrastructure, query optimization, access control, all of these things are handled by the cloud computing layer on Snowflake architecture. So I'll give you a simple use case. So let's suppose any user is trying to access my Snowflake database, a single database in my Snowflake. So is that user authorized to access that database? Or is that user, or does that user have the access control to access that database? What kind of authorizations does the user have to perform on that database, on the data set? So all these things, these are taken care of by the cloud computing layer in the Snowflake architecture. Okay, so these were the three components in Snowflake architecture. We have the storage layer, we have the query processing layer, and we have the cloud computing layer. The storage is responsible for storing all the data, structured, semi-structured, whatever it may be. The cloud computing layer is responsible for many important aspects from infrastructure, authentication, access control, metadata management, and the query processing layer is responsible for running up my queries. It is comprised of virtual data warehouses, and any query that any user is trying to run on any data set, that has to go through this query processing layer in the Snowflake architecture. Okay, so I hope this architecture part is clear. So now let's have a brief understanding on how to run Snowflake. So first of all, the most important point to note is that whenever we are trying to run Snowflake, we do not need any hardware, either virtual or physical, to select, install, configure, or manage. Everything is handled on a web browser. So we just feed in our Snowflake account login link, we log in and then start using Snowflake. Everything is done on a browser. We do have a few CLIs, but that is a part of future lecture. For now, just keep in mind that we do not need to install, configure, or manage any virtual or physical hardware. Also, there is virtually no software to install, configure, or manage. Important aspects like the maintenance, management, upgrades, and tuning, these are handled by Snowflake itself. So as a user, as an end user, I do not have to worry about anything like the maintenance part, upgrade part, management part, or the tuning part. Snowflake, it completely runs on cloud infrastructure. So we create our Snowflake accounts on either of the three public cloud providers, which are AWS, Azure, and Google Cloud. So it runs completely on cloud. So that is why we get all the benefits of cloud computing included in my Snowflake. And the components of Snowflake's service, other than the optional CLIs, drivers, or connectors, everything it runs in public cloud infrastructures. Snowflake uses virtual compute instances for its compute needs. So as we have discussed, if I have to run any query on any data set, that query is being run through a virtual compute warehouse. which is a part of query processing layer in my Snowflake architecture. And Snowflake cannot be run on private cloud infrastructures, either on-prem or hosted. Snowflake can only be run on public cloud providers, which are AWS, Google Cloud, and Azure. And also, Snowflake is not a packaged software offering that can be installed by a user. Everything from the installation to update, Snowflake manages all the aspects. Being an end user, I just have to feed in the login link of Snowflake, log in to my account, and then just start using Snowflake. So these were the points to remember whenever we are trying to run Snowflake for the first time. Let's just see quickly on how to connect to Snowflake. So Snowflake, it supports multiple ways of connecting to the service. We have a web-based user interface from which all aspects of managing and using Snowflake can be accessed. So as I've already discussed, we just have to use the login link of our Snowflake accounts. Once we enter the link in our browser, we just have to log in, and then we just have to start using our Snowflake accounts. Nothing more than that. No software to install, no software to manage, nothing. Just feed in the link. Once logged in, you are good to go to start using Snowflake. Talking about CLIs, that is command line interfaces like SnowSQL, they can access all aspects of managing and using Snowflake. We can also connect to Snowflake through ODBC and JDBC drivers that can be used by third-party applications, for example, TableU to connect to Snowflake. And we also have native connectors, for example, Python, Spark, that can be used to develop applications for connecting to Snowflake. So let's suppose if I'm using Spark and I have to connect to Snowflake. So in those cases, we have native connectors for that. We'll look into it into consequent lectures when we talk about how to connect to Snowflake through Spark, Python, etc. We also have third-party connectors that can be used to connect applications such as ETL tools, example, Informatica, and BI tools to Snowflake. So if I have to connect to any third-party tool like Informatica or ThoughtSpot, I can do that using third-party connectors that are provided in Snowflake. Okay, so that was it on the Snowflake architecture lecture. We got a little more deep. So the points we discussed had a look on the Snowflake architecture. Then we had an introduction to the shared disk versus shared nothing database. We saw the components in the Snowflake architecture. What are the three major components in the Snowflake architecture? Then we had a look on how to run Snowflake and also on how to connect to Snowflake. Okay, so that was it for this tutorial. In the next tutorial, we will see the practical, the hands-on on how to create Snowflake account, how to create a free tier Snowflake account, and how to log in into Snowflake through our accounts. So make sure to subscribe to the channel, guys, and I will be seeing you in the next lecture. Thank you.